Good morning, dear student. Today we will discuss about the last topic of class ninth physics, chapter 2nd, that is law of conservation of linear momentum. Up till previous period we already discussed about the inertia, first law, Newton's first law, Newton's second law, Newton's third law of motion, and momentum. In case of linear momentum, we know that linear momentum is the product of mass and velocity, and we also know that by third law, Newton's third law, the action-reaction force. We know that the action-reaction force is the opposite force. Both are equal in magnitude and opposite in direction. So let's start the law of conservation of momentum. Law of conservation of momentum. Dear student, at first the statement of law of conservation of momentum is, in any system the total statement of law of conservation of momentum is the total linear momentum of any system the total linear momentum of any system is constant until any other external force or any external force is not applied on that. The total linear momentum of any system is constant until any external force is not applied on that. In any law, if we have any statement, we have to proofs are there. So how can we prove the law of conservation of energy? We already have given in any system that total linear momentum is conserved. That means total linear momentum is constant of any system up till any external force is not applied on that. That means how can we prove the linear momentum is conserved? So if we have to prove the linear momentum is conserved, in that case we have required any system. Let's suppose we have two objects of mass m1 and m2, and both have initial speed u1 and u2. After a time interval, this is the time interval t equals to 0. After some time interval, the mass m1 and m2 both are collide. In that case, let's suppose time t equals to few changes in time. The mass is m1 and m2, and after that, after collision, both the object have a velocity v1 and v2. So now we have the system of two masses or two objects, and linear momentum is m1 u1 plus m2 u2. Here we have collision, and after that the linear momentum is m1 v1 plus m2 v2. Here the total linear momentum, let's suppose p1 is m1 u1 plus m2 u2. And here total linear momentum P2 equals to m1 v1 plus m2 v2. How can we prove that both the linear momentum are equal. As we know that Newton's third law of motion, here we have some collision, and if we have collision there is an action reaction force. If there is any action reaction force, in that condition both the forces are equal in magnitude and opposite in direction. So now we can say that here force acted by object 1 on 2 is equals to the force acted by the object second on 1 equal and direction is opposite. Now we can say that Newton's second law, force is equals to rate of change of linear momentum. So by Newton's second law, we can say that by second law, if we have F12 equals to mass m1, final velocity v1, initial velocity u1, and time is t. And similarly, by Newton's third law, and we have F21 equals to m2 v2 minus u2 upon t. Now we can say that this is force F12 and this is force F21, and both the forces are equal by Newton's third law, action reaction force. We can say that F12 equals to F21. Now we have F12 equals to m1 v1 minus u1 upon t equals to m2 v2 minus u2 upon t. There are, in both the condition, denominator is t, we can cancel the denominator t. Now after simplification we got m1 v1 minus m1 u1 equals to m2 v2 minus m2 u2. Now after simplification of these we got m1 u1 plus m1 v1 m1 u1 plus m1 u1 plus m1 u1 plus m2 v2 equals to m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So we know that in initial condition we have linear momentum is m1 u1 plus m2 u2, and in final condition the linear momentum is m1 v1 plus m2 v2. If this is initial condition and this is final condition, then we can say that after the derivation we can say that p1 equals to p2 and the linear momentum of entire system is conserved. By this way we can prove the conservation of linear momentum. We have few questions based on it. We will solve that numerical where there is any collision and initial mass of object first and the initial velocity is given, final mass and final velocity is given. We can find the missing term by this formula, that is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. This is the formula of law of conservation of linear momentum. By this way, by the sum of Newton's second and third law, we can prove that the law of conservation of linear momentum. Thank you.